Hello, Assalamu alaikum. Today we will see lecture number 36 from the subject numerical methods. Till now we did Newton-Cotes integration formula, and when we substituted different cases to the formula, we generated the formulas like trapezoidal rule, Simpson's 1 by 3rd rule, and Simpson's 3 by 8th rule. But it's not always necessary that in your examinations you would be asked all these three methods via the Newton-Cotes formula. So what you have to do is, if you would be asked to explain or derive the trapezoidal rule, you don't have to do it via Newton-Cotes formula. If it is mentioned to do it via Newton-Cotes formula, then and only then you can do it that way. If not, then you have to do it in this way. See the basic concept of trapezoidal rule. See, in this formula, I am having a curve and I want to find the area under this curve using the trapezoidal rule. What I am doing is, I am drawing a trapezoid under this curve, but still I am left with this much of area and it's very difficult to find the area of this curve. Okay, so what I want to tell you is, it is not possible to find the appropriate area under this curve, trapezoidal curve of f of x6. So what we do is, instead of that, we break this curve into smaller parts of uniform length and then calculate the area or length. Then we integrate the whole to get the required answer. We know that the area of a trapezoid is equal to half sum of parallel sides into b minus a, half of parallel sides into b minus a, which is equal to half sum of parallel sides, that will be equal to f of a plus f of b, into b minus a. The interval size between them is equal to h, so we can write it like h. We can also write it like half f of a plus f of b. Okay, this is how we can calculate the area of a trapezoid, which is given in figure A. Now, in the second diagram, what we have done is, like, the area will be equal to h divided by 2, because we have divided it into uniform parts like over this. Then there will be f of a plus f of a plus h, f of a plus 2h, and so on, plus f of a plus n minus 1h, and plus f of a plus n times h, isn't it? Plus the last term is f of b. F of a plus f of ah plus f of 2h. We don't know how many parts we have to do it. Depends on the area of a curve. That's why I wrote here so on, like that. Okay, this will be equal to h divided by 2 f of a plus, we can have the equal terms like summation of I is equal to 1 to n f of a plus I times h plus f of b. So this is how we calculate the area of all these things, right? Okay, now when it comes to this is the basic concept why we need to derive the trapezoidal rule and all these things, if we already know, and why we divide it into different parts. But when we have to derive it, we derive it, so we derive trapezoidal rule from the Newton's forward interpolation formula we get. For trapezoidal rule, we divided the curve into uniform lengths. And in the Newton Cotes formula, I told you that we only consider two data points whenever we have to generate the formula of trapezoidal rule. So from the Newton's forward interpolation formula, we only have to take the first two terms of the formula, like yk plus delta yk times u. You can write y1, y0, whatever. I just generalized it with k. It doesn't matter. So आप कंफ्यूज ना हो, चलो मैं इसमें ज़ीरो ही डाल देती हूँ, ठीक है. These things doesn't matter, okay? Okay. We know that our u is equal to x minus x0 divided by h. We know that our x is equal to x0 plus u times h. If we will differentiate this, d of x will be equal to h times du. I hope कि आपको differentiation integration आता है. That's why मैंने ज़्यादा कुछ लिखा नहीं. At x0 and u is equal to 1, at x is equal to x of 1, like that. Okay. So the first integral will be like this. We have to integral 2 points from 0 to 1, from 0 to 1, like this, y of d of x, which will be equal to 0 of 1, y0. Just substitute the formula in place of this, y0 plus delta y0 times u into d of x, which will be equal to 0 to 1. Okay, we'll substitute the value over here. So y0 plus delta y0 times u into h times du. You know that this interval is a constant, and there is nothing like, we don't differentiate constant, so there is no question of integrating, so we will keep it outside. y0 plus delta y0 times u into du. Now what we have to do is, we have to integrate it with respect to this u. So it will be like h of y0 times u. We can give the limits like 0 to 1 plus delta y0 times u ka square divided by 2. Put the limits 1 to 0 to 1. Okay. Now we only have to do the simple simplification, as you already can see. Okay, see. So it will be h of, this whenever we solve this will be 1 minus 0, and that will be 1, and 1 into y0 will be a y0. So that's what I will write over here, y0 plus delta y0, this will be 1 ka square divided by 2 minus 0 ka square divided by 2, that will be 1 divided by 2 into 1 divided by 2. Okay, h of, इसको LCM करेंगे, y0 plus delta y0 whole divided by 2. We can keep this 2 out, so we are having 2 times y0 plus delta y0. Now we can simplify this over here. h divided by 2, 2 times y0, delta y0 होता है बराबर हमारे y1 minus y0, which is equal to h divided by 2, 2 times y0 plus y1 minus y0, which will be equal to h divided by 2 y0 plus y1, isn't it? Okay. Similarly, if we have to integrate second integration from 1 to 2, it will be h divided by 2 y1 plus y2. Similarly, if I have to do the third integration from 2 to 3, it will be h divided by 2 y2 plus y3, and so on up to the nth integration, that will be n minus 1 up to n, that will be equal to h divided by 2 y of n minus 1 plus y of n, right? Okay, now this is something which we have already done, but the question over here is we don't have to derive this using Newton-Cotes formula. We can directly derive this from the Newton's forward interpolation formula. So summing all, we get I will be equal to the integral of 0 to n will be equal to h divided by 2 y0 plus 2 times y1 plus y2 plus y3 plus y4, so on, plus yn minus 1 plus y of n. And this formula is known as, this is a trapezoidal rule. Okay, it's very easy, there is nothing to worry about. Okay.